the technical discussions of this seminar. I hope you enjoy your break. Moving right along, we start the first section now. Let's say you are a proud owner of a gold mine, but you can't harness the gold from that mine. So what's the point in being the owner? Is there any? The condition is the same with big data. There is no point in collecting large chunks of big data if you fail to churn it and harness the information lying beneath it. To resolve this issue, data visualization tools are the weapons you need. These tools give us various insights of the collected data. Big names like Google and Microsoft collect and deploy big data to design the future of their business strategies. Today, we will look forward to get an exposure about what the best of the brains think about this very dynamic issue of application of big data and use of visualization, which will further help to transform the official statistical Anant to come on dais and chair the session. Let us give a huge round of applause and welcome him. Thank you, sir. Ladies and gentlemen, before the session begins, allow me to introduce our speakers of the session. First speaker for the session is Dipyaman Sanyal ji, Head Analytics Program at BIS School of Management. Sir is the Faculty and Academic Head for the Postgraduate Program in Data Science and Machine Learning, offered jointly by University of Chicago, IBM and Jigsaw-Academy. Sir is also the co-founder and head of GharValley.com, which is the India's first and only data science-driven automated property valuation system, a chartered financial analyst and recipient of the Commonwealth Scholarship. Dipyaman Sanyal sir holds a master's degree in applied economics from University of Texas and bachelor's and master's in economics from Jadavpur University, Calcutta. Sir, I welcome you on dais. Kindly accept a small token of gratitude presented by Ms. Jasleen Kaur. Thank you, sir. Now, I would like to introduce second eminent speaker of this session, Anurag, a management consultant of PriceWaterhouse India, which is the second largest professional services firm in the world. He also leads Digital Government Solutions team. Sir has more than 11 years of experience in management consulting. He did his MBA from the Vinod Gupta School of Management, IIT Kharagpur. After completing his MBA, he joined PwC. He has expertise in the areas of business transformation, IT strategy, business process improvement, process consulting, digital strategy, and digital governance, among others. You are welcome, sir, on dais. Please give a huge round of applause for him. Kindly accept a small token of gratitude presented by Mr. Jasleen Kaur. Thank you, sir. Moving forward, I would now like to introduce the last speaker of the session, Ms. Prukalpa Sankar, co-founder Socialcops, which is a data intelligence company that harnesses citizens' voice as a powerful resource and builds synergistic connected communities. She has been recognized by Forbes Asia 30 Under 30, Fortune India 40 Under 40, and among top 10 CNBC Young Businesswomen 2016. She has previously worked in the business division of Goldman Sachs and ExxonMobil. She studied engineering and entrepreneurship at the Nanyang Technological University, Singapore. Please welcome her. Now, I hand over the session to the chair.
Well, good morning, everybody. What we will do is both Mr. Dua and Ms. Sankar have very small presentations to make. So I request them first to make their presentations. After that, Mr. Sanyal will briefly just talk about some issues, and after that I'll open up the session to the floor. You can have an interactive discussion with them based on what they've said, and this is an open area. There's many issues there. I'm sure these people will be able to react to your queries and questions. So without much ado, I'll request Mr. Dua to make his presentation.
Very good morning to all of you. Thank you so much, ISS Association, for having me here. I think I should give a pat on my back for being courageous enough to talk about analytics in front of all of you. So I hope I'll be able to do justice to this. I'll run through a very small presentation, though my profession itself makes me talk at length on lots of issues, but I'll try to be as precise as I can be. I was hearing the sessions in the morning, and we did touch about on the subjects of big data, technology advancement, and all these things. I'll start with a very small thing. I think all of you in the room, or most of you in the room, must be using somewhere something called as Google Maps. I think that's a very powerful demonstration of what do we mean by the big data as well as the visualization part. So if I can just combine both of these things into this. Now, if in our personal lives, big data as well as visualization can be as strong as this, just imagine the power of both of these put together in our official lives, in our professional lives, or in the larger governance scheme of things. So very quickly, before I move on to the technical part, we just wanted to talk about the fact that what is something that is driving all these things today. Why are we even talking about these things today? And the way we look at it, or the way I look at it, is more from the fact that how the governance shifts are happening in the society, and that is something that is making up the need of all these things, of the way we are talking about the data, AI, machine learning, and all these aspects. And when you look at it, some key things, I'll not go through the entire slide, but there are a couple of things such as the connected ecosystem that we have started living in, the technology advancement that has happened over the period of time. Not only that, the way the expectations of the citizens have changed over the period of time. We are now looking at Google class experience, or if I can use that word, in all of our interactions with the society, with the government, and in the private sector also. Now with all these things, digital has played a very key role in being a strategic enabler for us to achieve these things, be it on the governance side or on the citizen side. And digital having played such a strong role, it has led to a phenomenal growth of data. And if I look at just three key trends, the information as such is growing at an exponential rate, driving value from that information is required, and then the challenges that are being faced are also very daunting. I'll just touch upon one point on that. So while we are talking about all those things, I think one of the key things that we need to be a bit careful about is the issues regarding the guaranteeing the safety of data, security, establishing the right standards, and governance. So doing all these things in terms of AI, whatever name you give it, big data, visualization, and all those things, since we are talking about so much data, how do we ensure that the data is adequately safeguarded? We did a small research, this was a couple of years back, on how the data is being used in the domain of the governance, and this was not an India-centric research, this was a global research that was done. And it was found that still more than 50%, I would say, though the statistics here are showing around 90 to 95% times, the data that we were using was more for the reporting part, the transaction monitoring part, or the control reporting part. We need to move from that direction to a direction where we are saying that more than 50% of the times we are using data for decision support. And how do we really do that? So when we talk about big data, and I would not get into the technologies, what does big data involve or entail, but just if you look at the conceptual part, and that's how we define big data, where we say that how do we transform data into the insights and intelligence, and how do we ensure that the right decision is provided at the right point in time. And the canvas for which this all can be used is really, really wide. So you can talk of things such as using big data during the time of elections for targeting micro-constituents, or using genome analytics. So the use cases are simply very wide. And when we say big data, what do we really constitute? And there are no boundaries, I would say, when we say what is big data and what is the traditional data. But if you look at big data, and we were having some discussions earlier on in the sessions also, you talk about anything, you talk about industry data, you talk about financial data, you talk about climate related data, social data, anything and everything now we are talking about as big data. And the core transactional data basis which the policy making was being done till some time back is still there. And when we combine both of these things, we say something called as intelligence in the moment. And definitely technology is playing a key role in all these things. We have enterprise data platforms coming up. So that's how we define big data, and that's how we see the usage of big data. And when we talk about its benefits, I think it is in terms of all the dimensions. We talk about better service provisioning, we talk about improved policy making, and we talk about increased productivity within the government. Just to talk about some use cases, I've got an opportunity to work on certain key engagements, transformation engagements that are happening in the country, be it on the side of GSTN, where we are talking about collecting crores of invoices every month. How do we analyze data on that? Be it in terms of fraud management in the case of subsidies, be it in terms of the clean money project, where data from various sources is getting aggregated and analytics is being performed on top of that. So multiple use cases are there in the governance case, and if you look at more from official statistics perspective, so that's a big use case. Very quickly running through some of the cases which we have been doing. So you look at the disease outbreak prevention, where data from multiple sources, be it weather related data, hospital related data, social media feeds or traveler related data is collated, and the big data platforms are being used to prevent the diseases outbreak. Healthcare definitely one of the biggest use cases we were talking about as disease in the morning, and if you look at the health related dashboard, it happens to be one of the biggest use cases for the big data itself. So be it in terms of public health, evidence-based decision making, genome analytics, or the device or the remote monitoring of the patients. Traffic, I think these are some very common use cases I wanted to touch upon, where how do we aggregate surveillance related data, weather related data, emission related data, and we can do better traffic planning. Predictive policing is being used in lots of cities now across the globe. In India also, efforts are being made how do we do predictive policing using the big data techniques by collecting data from sensors, from various other devices. Now, big data, again, that's more of a back-end thing of how do we actually analyze the data. But what gets shown, I think it's one of the key things, and this is where the visualization comes into picture. So that's what we say, that the data visualization leads to smarter decisions. So what type of visualizations are we creating? These are some sample visualizations. This is a visualization where we are talking about how can we understand the performance of various industries, stroke services, stroke other things in a district, and on a map, on a meter. So there are various techniques that are being used now, and the output or the decision making is as strong as we can get the visualization aspects of these things in front of us. We were hearing about the concepts of artificial intelligence also, and that is again something that is being driven completely through big data. So that is again something that is playing a key role now, and this is where we are moving to when we talk about AI, NLP, machine learning, and all these things. Just last couple of minutes, one of the things that at least in my experience has been that using these advanced techniques within the government sector, we do face a lot of challenges at times, sir, in terms of what are the tools that need to be used, what are the people that are required, do we have the data scientists available with different departments. So how do we look at a scenario where a nodal department, a nodal ministry, possibly MOSPI, can play a role of something like like providing data analytics or big data analytics or whatever you call on a cloud within the government setup. So this is more from an execution model. I just wanted to touch upon these things that probably one is that usage or the use cases. Second, how do we exactly put these things to use? So that happens to be one of the models where the entire technical skills, the applications, the data, everything is provided by a nodal department or a ministry, and then various other government departments become a user of that data on a cloud. And since this happens to be a government-owned thing itself, there are minimal data privacy or data security considerations also that come into play. Last, just to end up with an example, we did an exercise. This is an Australia example. We did an exercise where we said that what is going to drive economic growth in the country going forward. So a lot of data was collected, basically the demographic data, the data of the transactions that were happening in the country. This was the entire data fusion was done. BI and big data techniques were used. I'll just come to the last part, though there was a video, but I think I'm running short of time. I'll skip that. So this is something that we came up, something called as Insights for Government, and I'm just showing a sample map. I know it might not be very visible, so apologies for the representation on this. But such visualization maps were created where we said that how different cities are performing, what are the industries that are there in different cities, what is the output of those industries, what is something that the government should do in some of these areas. So that's the power of visualization, that's the power of analytics, and this is the world where we are living in. I don't think it's a matter of choice now, should we do it, to what extent we do it. I think this is something that will be driving decision making in the government going forward. Thank you so much.
Thank you, Mr. Dua.
Hi, good morning everyone. My name is Prukalpa and I'm the co-founder of a company called Socialcops. We're a data intelligence company and we enable leaders in organizations including the UN, World Bank, Government of India, Niti Aayog, Ministry of Rural Development and so on and so forth. So I think everyone today has talked about the importance of data-driven decision making and I want to tell you a little bit about the story of how we started. So a couple of years ago, my co-founder and I moved to India to bring the same precision that you see in financial analytics to decisions that matter. Why can't a national level healthcare budget be allocated the same way that a financial portfolio is allocated in investment banks? And the biggest challenge that we found in data-driven decision making is often the data itself. Data in the developing world continues to often be collected on paper or non-digital formats. Very little of this data actually makes it to digital formats. When they do make it to digital formats, it's unstructured, it's in PDF files, it's in local languages, it exists in silos. And often bringing all of this data together is a nightmare beyond recognition. So to give you a sense, the first time we mapped two data sets at a village level in India, this is census and DICE, which is the education data set released by NUAPA. You'd think it's relatively easy, table with village names, map the two tables. We got a 15% match, 1-5, because Pomburna can be spelt with a B or a P. In India, Manrega recognizes 10 lakh villages, census recognizes 640,000 villages. And all of these are very real problems that exist before being able to even talk about data analytics and visualization and AI and machine learning and so on and so forth. The silver lining that we found through all of our learnings has been that despite all of this, if you somehow bring data together and showcase it in the most intuitive fashion to decision makers, red, greens and yellows, they may not understand data, but they will understand their programs really well. And they will make decisions of it. And so we realized that it's important to flip the process of decision making. Unlike in the developed world, where you can start with the data that you already have, apply a data analytics platform or a big data platform on it, and use it to drive decisions. In a country like India, you need to flip this. So essentially, that's really where data intelligence started, and it's a relatively nascent field globally. We started the decisions you want to drive. These could be strategic decisions. We need to drive the gas distribution strategy of India. Where should we go open the next 10,000 LPG centers? Or it could be operational decisions. Where is my process breaking? What do I need to do to hit my KPIs? And we work backwards from there to get all the data that you need to make it happen. What I'm going to try and do is actually show you a couple of examples of how applications like this have actually been put to use from a Government of India perspective. So I'm going to start out by showcasing some of the work that we've done with the Ministry of Petroleum. And this was when the Pradhan Mantri Ujjwala Yojana was being launched. And as you know, Ujjwala was essentially creating a lot of demand for LPG, especially in rural areas. And as more and more customers started getting access to LPG, another challenge emerged: infrastructure. The government needed to be able to provide LPG distribution centers within 10 to 15 kilometers of households of citizens. Now this is a dual problem. An LPG distribution center is something that's owned by an entrepreneur on ground, so ultimately it needs to be profitable. On the other hand, government is providing a subsidy. Government wants to create access. You want every one of Indian citizens to have an LPG center within 10 kilometers of their homes. So what we did was we essentially started out by building the first layer of data that came in from sales and marketing of the oil companies. That became the base layer of data. What we did on top of that was add a layer of public data. So we mapped every one of India's 640,000 villages, layered it with information like affluence, LPG penetration, so on and so forth. And then, as often happens, we realized that there was a data gap. We didn't have locations of existing LPG centers. And so we deployed an Android app, much like what is being used outside to collect data for the surveys. Works completely without internet, works in local languages. Within 1 month, collected the lat longs of all of these LPG centers. And that we were able to create a base layer of information that we could then use to create all the information that we need. So I'm going to dive deeper into actually one district and show you. So we're actually in the district of Sundargarh in Odisha. What I've layered on top of this is actually a layer of LPG centers. So if you see, each of these points are LPG centers. What you're seeing at the center is actually the urban area. So if you see, there's a large concentration in urban versus rural. On top of that, what I'm layering is all the villages. So if you see, each of these green dots are all the villages in this district. Now some of these villages already have access. So I'm going to add another layer. So if you see the blue dots are the villages that need to be given access. Remove that layer. Now on top of this, we ran a geo-clustering algorithm, divided all of these villages into the minimum number of clusters that you need to give access to. And on top of that, then we started identifying market potential. So I've layered two things now. So if you see the green clusters that you see are actually places that if you go and open a center today, it will be profitable. We looked at multiple statistics beyond this. So for instance, rural consumption typically tends to follow urban consumption. All of these different algorithms that went at the base of all of this. The purples are places where it will be viable within 3 years to open a center. And the blue are places where it will never be viable. And this way we were able to create, sitting here in Delhi, a strategy for the entire country, saying where exactly do we need to go and open centers. And then we took it one step further. We used a location potential index to identify. So typically a center should be a place where there's a bank, there's an ATM, a road should be there so the truck could go in and out and things like this. All of this was data that was coming from almost 600 different public data sources that were collated, brought together. And we actually were able to pinpoint the best location to open a center on the basis of all of this. At this point in time, and this was field verified, at this point in time about 6,000 centers have already been commissioned on the basis of this algorithm that's driving this. And the entire manual process that used to happen before that has completely been scrapped in the oil companies industry and the Ministry of Petroleum. I just want to run you through some other examples of how this could typically be used, right? So I showed you one example which was very, very local, hyper-local geo-targeting. Some other examples are essentially wherein how do you start, if you're making an investment allocation on where you're going to look at spending money, how do you make that investment allocation? So this was actually a use case around investing in agriculture. But agriculture is not something that occurs in silos, right? In a country like India, development is something that happens holistically. So for instance, if I'm investing in crop productivity to improve pulse productivity of masoor dal, I'm also going to affect nutrition outcomes in that area. So how do you look at all of these data sets together to make that investment allocation decision? So we brought together about 32 different data sets across nutrition, economic agriculture profile, things like this. What you're seeing is actually chloroplet maps where in UP. And you can look at all of these different indicators, about 209 indicators on the map live. And all of these visualizations are things that actually are customized to the indicator. So for instance, when I look at something like wheat productivity, the size of the circle tells you the area of cultivation, the color tells you the productivity of the crop. So things like that enable better decision making. And you can essentially then also go in and start querying, add layers one on top of the other. So I'm going to going back to my nutrition example. If I want to see places where nutrition is lowest, and infant mortality rate is something that could be used as a sort of proxy there. I'm going to just add a query that says top 25% infant mortality rate in UP. And if you see, there are certain districts that got colored to match that. Then on top of this, you could add a query that says, say for instance, crop productivity, show me places where productivity of masoor is in its bottom 25 percentile. And now if you see, we're actually down to 4 districts in UP out of 75. And you can actually go a step further. It's a water intensive crop. So if you need to grow it, then you need access to irrigation. Add another layer and say for instance, show me places where percentage of say net irrigated area is in its top 50 percentile. And I could add a query. And if you see, that way you can start actually drilling down deeper and deeper to actually come down to what are the exact locations that you could go up, and if you make this investment, you can actually have the maximum ROI on social impact. Similar tools can be used. I mean, I talked about strategic decision making. Similar tools could be used for live tracking, monitoring purposes. So for instance, this is actually a live dashboard that was used during the implementation of Ujjwala, which shows you your top KPIs, pulling it from all these different databases, bringing it in one place. If you see, essentially I can go backward and forward in time. These are KPIs that get updated on a daily basis. And we were able to use this in a way that was able to drive live real-time decision making. So for instance, if you see reasons for rejection, we found early on that people were getting rejected because of lack of bank accounts, which doesn't make sense because Government of India has Jan Dhan Yojana. And a simple order was passed to say, no one will get rejected because of the lack of bank accounts, and let's do convergence with Jan Dhan Yojana programs. And visualization tools like this were able to bring about information in one place. And all of this is information, mind you, that's coming from very different sources. So it's not like it's a clean, structured database and we're just pulling data from there. We're bringing together all of these different data sets and making them talk to each other to be able to drive insights such as this. In the last few years, we've seen how data could be used to drive potential disruption in the way decisions are made. And one of the most exciting things, and the last thing I'm going to show you, is something we're very excited about. We're working with the Ministry of Statistics, Niti Aayog, and the UN on building a life tracker for the Sustainable Development Goals. This is something that's bringing together data from about 100 different public data sources, and eventually the aim is also to layer this with government programs and schemes data. And if you see, essentially the intent is very much like what I told you before, the ability to be able to go into different goals, look at where India stands against each of these, layer this, so if you see, maternal mortality rate, proportion of institutional delivery, toggle this by performance, see which are the major, indicators that we're doing well at, where are we not doing well, and then the ability to actually start going deeper and deeper into each of these different indicators. So say for instance, if I want to go into proportional of institutional deliveries, being able to look at this on a map, being able to look at it on a district level, toggle backward and forward in time. And the intent is to be able to sort of take this one step further, and how do you make this a live decision-making tool for everyone who's working towards being able to achieve the Sustainable Development Goals. So the layer that we're hoping to add onto this is actually a layer that brings together data from government programs. So for instance, if I'm someone who is working in the National Health Mission, how do I start looking at indicators, my indicators, things that I look at on a daily basis for my scheme, and have the North Star of the Sustainable Development Goals to see is it leading to the larger global agenda. So say something like antenatal coverage within the first trimester, which is actually something that's very important to be able to hit your larger maternal mortality goal. Being able to go deeper in that, and the layer that we're looking to add to this is actually something that we're calling trigger indicators. So for instance, if I'm a decision maker and I look at something like antenatal coverage, and I know I need to improve antenatal coverage, but how do I improve antenatal coverage? That's where these action points come about. So antenatal coverage is something that can be improved based on the number of primary healthcare centers per 100,000 population. Janani Suraksha Yojana registrations. These are all core decision points or action points that a decision maker can look at and say, these are the 3 things that I can action on so that I can actually improve antenatal coverage and by default improve maternal mortality rate. So that's overall sort of what we're trying to bring together. And the intent is that this becomes a tool that can be used across government and decision makers to be able to drive live decisions. So, yeah, that's to give you a quick sense of the kind of things that are possible in governance, and we're bringing big data together to make it happen. Thank you.
You want to stand up and speak from here? Okay.
So, no, I don't have a presentation. I spend quite a bit of my time consulting for companies and the rest of my time teaching, so chalk and talk, right? So the question is, the Wired magazine wrote an article recently and it asked us, is statistics dead? And that's what I want to talk about. Is statistics dead? Right, and it's a scary topic to discuss in a place like this, a room full of statisticians who are going to kill me before I leave. Then we won't have this discussion anymore. And I'll tell you why I don't think it's dead. It just transformed. Right, it's changed. It's changed because very often, and we saw some presentations here, and I've seen quite a bit of work that these guys have done. Fantastic, good stuff. But let me tell you, the last data set that I was working on, about 11 million data points on peer-to-peer lending markets in the United States, I was working on a laptop this size. So it's not big data. Right? That's a tough claim to make, but it's not big data. What's going on is, like, we love jargon. Right? We came up with data science, we came up with analytics, we came up with predictive models, we've come up with machine learning, artificial intelligence. We keep doing that, and because it sounds good, and as a consultant it gets me more work, which is great, right? Which is why statisticians believe in Greek letters instead of English letters. We like that. We like Greek letters, right? Of course. It looks fancier. What's happening is that there is more data. There's tons more data, but very, very few of us actually need to use big data. A lot of the data at the government level, unless you have individualized data, it's not big data. Even district level data is not big data. Right? It's small enough. You can work with the tools that you have. What's changed though is, when we did statistics back in the days, right, as an econometrician, as an economist in graduate school, we were told that data mining is a dirty word. Don't use the word data mining. Data mining is wrong because you're looking for patterns which may or may not exist in real life. There's an underlying theory, there's a beautiful bell curve, right? And from there we come up with these beautiful regression models. And then I went and met these machine learning guys, these computer scientists, right? And now I even work a lot with physicists. There are this group of crazy people called econophysicists, right? They take this physics math and use that for economic problems and sociological problems, and I work with them. And they believe that let the data speak. Forget about the theory. They have physicists of lots and lots of stuff where they model the data first, and the theory came in much, much later. They didn't know what the underlying theory was. They just knew how the gas would move when you give heat, from the data. So that's the machine learning way of looking at data. Let the data speak first, and then I create a model. As a statistician, that's counter to a lot of things that we have learned because we begin with theoretical statistics. Yeah. So I think analytics, or whatever you want to call it, is kind of a marriage between these two things. Right? So all we need to do as statisticians is probably reskill ourselves a little bit, learn what the machine learning paradigm tells us, and start learning some of the things that we need to, like data visualization, which is going to make a huge change. Because a lot of the insights that you draw seem to be dry numbers, and when you take it to the ministry or any decision maker, right? Because this idea of the public sector not doing stuff and not doing much with the data, the private sector does exactly the same. I consult with many of them. Most of their data is sitting somewhere in this huge database. They have 20 IT people, kind of petting it every morning. They don't do anything with it, right? Very few people do. So the key change is that we will have the data, we'll have your skill sets, you'll need to reskill, you'll need to understand what machine learning is, you need to understand what the big data paradigm is and what data visualization is, stuff like this, which makes it pop out to the decision maker, and that's where you're going to get the support from. Yeah. The power of these algorithms are incredible. I had 4 students, 22-year-olds, right? And seriously, they knew nothing about anything, right? These are 22-year-old students. And before the UP elections, we did a study. We downloaded tons and tons of data from Twitter, right? And you know that not a lot of people in UP are using Twitter, right? We drew out a ton of data from there using the API that Twitter has into a software called R. And these guys did a bunch of sentiment analytics and text analytics using these lexicographic models that we have. And about 12 days before the election, these students of mine, they came up to me and said, hey, it's going to be a clean sweep. Yeah? I didn't believe them, of course, because I have friends who are psephologists for televisions who had no idea what the hell was going on. But my 22-year-old students were right. And I was very queasy about talking about this before it came out. Yeah? Cambridge Analytica, a firm based in the UK, small firm, essentially helped Donald Trump win the election. They did individualized profiles of 210 million US voters and knew exactly who to target and when and how. Right? And these processes are not very difficult. Right? There are tools which are it's here. It's not very difficult. It's out there. A lot of it is open source. I think what's lacking right now is beyond the verbiage and the jargon. We are covering up a lot of very insightful things that we have access to, right? And so somebody needs to democratize it, and who better than you guys, yeah? So that's all I have. I mean, it's going to be a game changer. It is becoming a game changer, and I think you'll see huge social changes coming from artificial intelligence and machine learning. Especially after the implementation of multi-layered artificial neural networks, which we are using now, deep learning, that's the new buzzword. But you'll see a ton of unemployment maybe, right? As statisticians, as policymakers, as economists, I think we need to make sure that, despite what Gartner says, so Gartner had a report yesterday which said that AI will create more jobs than it will kill, right? Take it with a pinch of salt, all right? You heard it here, take it with a pinch of salt. Yeah, a lot of repetitive tasks, especially in certain key areas like IT and such, will be gone. We know that. As policymakers, as statisticians, I think it is time for us to think about these problems and start using these tools which are fairly accessible to visualize the data, to make sense of the data, because you are already collecting tons and tons of information. And one thing that I keep telling my students, I'm going to repeat it here, life always doesn't give you big data. Life doesn't give you big data. It rarely does. You don't have terabytes of Twitter data sitting with you. You work with small data, and small data is enough. You don't need big data, often. All right? Yeah, thank you so much.
Since we're running a little behind schedule, what we'll do is we'll defer questions for now. I would have, maybe there will be some time for discussion after the next session, I gather. Is that right? So you had three extremely insightful short points about different facets of how various agencies in the private sector are working with data and so on. I think, you know, when I made my opening remarks today, I mentioned the fact that we need to build a larger community. And in some sense, the traditional statisticians have a much larger community of people they need to talk to, and that community includes a variety of people who are now involved in the field of data. And they're not just traditional data scientists, they're not engineers, they're not software people. There's a whole bunch of people who are involved in this, and everybody is in the game now of, so to speak, of working with data in some form or the other. It makes your task much more difficult, because ultimately government turns to you whenever it needs to understand. So I think your job of listening to all of them and to sort of listening to all this work which is happening in the world of data and analytics is something which you have to internalize as part of your makeup, so that you provide the filters by which government will then be able to make sense of this enormous amount of capacity which data has created. So with that, I'll stop the session here, but we'll be able to come back.
So you can permit few questions.
We can?
Please, permit 2-3 questions.
Please don't make questions, sir.
A few questions.
Okay,
please.
All right. I will defer to all right, a few questions.
I have a question. I'm Rohit Bhardwaj. I'm 98 batch ISS officer. Glad to hear, Mr. Sanyal, your point of view. Tim Gartner said that big data is dead, and it removed in 2015 from its jargon big data. And I just wanted to understand what the way these analytics are being shown, and we as traditional statisticians, we work on model, we fit the model, and then we find that, you know, the reasons for it or the observations for it. I was looking at the action point, Ms. Sankar, you were showing us. Can you just explain the reasons of taking those variables? Is it that those data only available, you took those variables to trigger an action point, or there was a logical regression model or any predictive descriptive model behind it? Can you please explain that?
I'll do one thing, Rohit, I'll ask them to hold on the response to that. Let me ask people if there are one or two more who wish to make, like Rohit, very sharp, very focused, very good questions. If they can make them, then I'll request the speakers to react to that. Anyone else? Okay.
My question is to
Mr. Sanyal. You said that you predicted the UP results using the cheater. Have you done the same for Gujarat? And if yes, how many seats?
I think that's a question we all want to hear the answer. Anyone else? All right.
I just wanted to emphasize that he said the right thing, that big data and data analytics is actually, we as a fanciful word, we use big data. The essential part, the most essential part is the domain knowledge. Without the understanding of domain, you will not be able to analyze anything. Garbage in, garbage out, it has been long, we have been using computers for long, so we know that so what Rohit asked was a very valid question. Like, you have identified few indicators. Whether these indicators actually reflect the phenomena what we are measuring is the work of a statistician or economist who will understand, who will get into the domain in which the data is getting generated, whether the indicator is a biased, unbiased, all those statistical things are there. So understanding domain, then only will get to a particular indicator, yes, whether this should be there or not. Because just because it is being collected and we have used it and we have developed a decision-making model on it, is probably not the right way. So statisticians definitely have a very, very significant role, I feel personally, and domain knowledge, yes, it will come out of my experience of working in the particular field, whether it is health or education or whichever field. Thank you.
Okay. I'll give the floor back to each one of you 2 minutes to start.
I think in some ways, I think Sir just answered some of the questions that you had raised. And you're very right. I think couple of things. I think in most parts of India and in most work in government, we're not really working with big data. We're working with data, but we're not really working with big data. Very few places, maybe probably in India, a company like Flipkart would actually be working with data that could actually be called big data, in which case you throw data in, let the system give you an answer, don't worry about domain knowledge and things like that. What we found works really well is to be able to work very closely with domain experts as well as work with field knowledge as you're creating an algorithm. So I'll give you an example. For instance, in the first time we created the location potential index and the clustering algorithm in Ujjwala. The first state that we tested it in, the algorithm success was about 70% against the final location that was actually picked. And this was actually sent back to field. Every district level coordinator actually responded saying, does this actually make sense at a ground level? What we realized was that the algo was not using population density as effectively as it could. Central UP and Hilly Odisha are very different in India. You cannot use the same algorithm to actually define how many centers need to be opened and where. So as we started getting feedback from the field, the algorithm started getting tweaked. And actually by the time we got to our third state, which I think was Gujarat, we were almost at a 96% accuracy because we had tweaked it on a consistent basis. And I think that's what we found in terms of actually being able to build out these models, in terms of being able to build out an algo that can actually give answers, figuring out trigger indicators. It's not something that you can expect, let's all sit in a room and let the system give you the answers. That typically does not work. It involves working with domain experts, it involves building out a first model, it involves testing it on the ground and then continuously tweaking it until you get to 100%. So for instance, in the case, in the specific case that I told you about trigger indicators, of course some of it is limited by the data that we have, but we're working with domain experts. Niti Aayog, Ministry of Statistics is coming in to give us a lot of expertise. The UN agencies are coming in with domain expertise to actually being able to define what are the triggers that could go in. And hopefully as we put this in the hands of decision makers, there'll be feedback that comes in and the system will learn over time. So yeah.
I just add a small point. Sir, you were mentioning about the fact of the domain expertise. I was reading a book some time back. I don't recall the name of the author. I think it's Martin or something. But the title of the book, I remember, it is called Small Data. And there was a case study, though not in the government domain. So this was a case study of Lego toys. So one of the very famous case studies where the company was almost dead at one point in time. Though they were using a lot of so-called big data. I'm not getting into the debate what is big data, whether it's just a buzzword or there is something behind it. But the company was almost dead and they were collecting lots of data from lots of places and they were applying that data to come up with some analysis. And the analysis that they did was that we should move away from the current era of toys and we should get into something new because children are really not interested. They are more interested in the video games right now. This gentleman who has written that book, he happens to be a consultant, brand consultant and data consultant. He came up and he has written that the fact that understanding the psyche of the children and how does that get into the analysis. So he made lots of visits and Prukalpa was also talking about the fact that how do we use field inputs into the analysis that we do. So what he did, he actually went over to lots of places, he analyzed, he talked to lots of children and then those inputs from the field actually went into the analysis once again. And later Lego came up with a strategy that let's continue with this only with some tweaking here and there, and the idea was that how do we make it more interesting for the child, and today they are a big success. So absolutely sir, that's how it is typically done. Big data, not big data. So big data again, that's more of I would say a word that we use. It's more to do with the fact that we are just collecting enormous amount of data now compared to what we were using earlier.
Just make a couple of quick points. So on the question on variable choice and kind of rides into your domain question, I think one of the key skills lacking is what we call feature engineering or variable selection. We don't know which variables to use, right? And there is no right answer. There is no right answer that this is the right variable, because it's kind of a circular problem. I am trying to push for evidence-based decision making, right? So how can I just ask 3 domain experts, what are the useful variables? Because they are coming out with a gut feeling, right? And then I'm saying that, you know what, I don't have the time or the budget to get 20 variables or 50, right? I don't have the time to do that, neither the money to do that. So what we do is we test out a bunch of stuff, right? So the point is, yes, domain experts are essential. But if you get 3 economists in a room, they'll have 30 different points of view, right? We know that. Yeah? And same with statisticians, kind of. So what we do need is that we should not identify domain experts in the traditional sense of the term, right? So if we are dealing with the economics problems, right? Let's get a physicist in the room. Let's get a sociologist in the room. Let's get a couple of psychologists in the room. Let's see what they have to say. And within these, right, let's think of 20 different variables or features, and let's A/B test it. Let's run one set of questionnaire in one village and a couple in somewhere else, and so on, right? So domain expertise is essential, but the problem with domain expertise is we get bogged down in silos. We are in a box and we don't want to see out of the box because out of the box is very problematic, right? I'm here, I don't want to go there, right? So that's the challenge with domain expertise. However, yes, absolutely, that's the first step, and that's how we do feature selection, feature engineering. It's one of the biggest challenges, right? Data cleaning, as was mentioned, right? How to get clean data and how to do feature engineering, which features are essential. These are the biggest challenges that data scientists face all the time. About your question on Gujarat election, have we done the study? We have not, but you know what? It's not very difficult to do if you think it.
I knew that.
We can do it. We can do it, and I can send it out to you. It should take a couple of days. We can run the algo and we can send it. Yeah, no, we did predict using similar algorithms the German election, and that worked. So that's pretty cool that we could use